All right, in our first unit where we're introducing chemistry to you all, we are going to do chapter 1 and chapter 2 together because in the textbook they're very short and they go together and they introduce chemistry. Now, if you remember from the previous chapter, chemistry is the study of matter and the changes that they undergo. So, chapter 2 is matter and change. Look at that. We're taking a little bit of a deeper look into what chemistry is. All right, so first things first. What are we going to see here? Well, what is matter? All right, matter is anything that has mass and takes up space. So, everything around you. And what is mass? Mass is the amount of matter that an object is going to have. So these two definitions are cyclical. So you can't define one without the other. And one really big misconception is that mass is the same thing as weight, which it's not. And we're going to talk about mass when it comes to density and volume and stuff like that. So, what is weight? Weight is the effect of the gravitational pull on an object. So it's going to depend where you are in our universe, or in other parallel universes for that matter, as to how much you weigh. So you are going to have the same mass whether you are on planet Earth or on our moon, but you are going to have different weights. And the reason for that is because the Earth is going to have an acceleration due to gravity of 9.8 meters per second squared, and the Moon, oh, I don't remember the exact amount, but it's 1/6 less that. So if you look at the videos of the people walking on the moon, they kind of have like a bounce to their step because they aren't being pulled down to the center of the moon with as much force. Okay, there's less gravitational force. Back when I started teaching in 2002, before the Google was, the be all end all, we had different websites like onlineconversion.com, which I still visit once every year, especially when I'm doing this stuff. So you go to onlineconversions.com. You go to fun stuff, and then they have this whole thing of like weight on other planets. So you can enter your weight in here, hit calculate, and it'll tell you how much you weigh on the other planets. And so if you weigh 125 pounds here on Earth, you would weigh 47 pounds on Mercury, 113 on Venus. They are approximately going to have the exact same amount of gravitational pull here, but the moon is 1/6 that of ours on Earth, so you would only weigh 20 pounds. You wouldn't be like teeny tiny. You would still take up the same amount of space. You just would weigh less. Mars, and this is a big issue I have with the movie Martian, okay? Mars, they're not bouncing around. Matt Damon isn't bouncing around like he would be as if he were walking on the moon. The gravitational pull on Mars is going to be far less also. So, I'm the worst to watch sci-fi movies with because I'm like, that's not possible. That's not possible. My husband like freaks out all the time. He's like, just shush. He's like, suspend your disbelief. I'm like, oh, Jupiter, man, you would weigh 295 pounds. So that's going to be more than double. So what does this feel like? It means you are being pulled down more. So if you've been on like the gravitron, like at June Fate or something like that, and how you're like stuck against the wall, that's what it's going to feel like when you're on a place like Jupiter. Saturn is pretty similar to that of our planet, even though, it's all that gas and stuff. Ooh, Uranus. Gotta love that one, teaching teenagers about planets and saying the word Uranus. That's going to be 111. Neptune is about the same. And back when Pluto was considered a planet, you would only weigh 8 pounds. Ooh, yeah, teeny, teeny, tiny amount. It's going to have so much less gravitational pull. Now, what would happen if you could survive walking on the sun? If you could be Icarus for a moment, you would weigh 3,384 pounds. Ah, crazy. but the gravitational pull of the sun is so strong that it keeps the planets in orbit, and you would be, reduced down, if you didn't burn, into a teeny tiny little blob of you. So yeah, so that's always a fun little thing to go through. So check out onlineconversion.com. It'll definitely helps you pass the time. All right, so when we study chemistry, we're studying matter and the changes that they undergo. So first half of the year, we're really going to talk about matter. Second half of the year, we're going to talk about their change. All right, so this slide right here, this little graphical organizer, you want to star, circle, highlight, because it really does um, put together a nice little map of what we're studying when we study everything. Okay, matter is broken up into two things. It's broken up into pure substances and impure substances or mixtures. Okay, impure is just they're being snobby and scientific. All right, and your pure substances are either going to be elements or compounds. Our elements are found on the periodic table, and they are going to be broken up further into metals, into nonmetals, into metalloids, and into our noble gases. Okay, so we're going to study this part first, half of the year. We'll still talk about this other part over here when we talk about our mixtures, because mixtures can either be homogeneous or heterogeneous mixtures. Homogeneous meaning the same, so it's going to be consistent throughout, like salt water or alcohol or tap water. Heterogeneous isn't going to be consistent. You're going to see different parts around it, like homogeneous and heterogeneous, or sorry, homozygous and heterozygous, like you learned in bio class. So, like soil, wood, rocky road ice cream, a salad, a cheesesteak, all that kind of stuff is going to be a heterogeneous mixture. So we will actually refer back to this classification of matter table a lot. It really does help. So matter, like I said, is is going to study our substances, and a substance, also called a pure substance, is really going to just have one type. Like sugar is going to be carbon, hydrogen, and oxygen in a certain variety, depending on what type of, or in a certain ratio, depending on what type of sugar, whether it's fructose or whether it's glucose or it's going to be sucrose, maltose. Okay, there's all different kinds of sugars for how many carbons, hydrogens, and oxygens there are. Salt, our good friend NaCl, is going to be consistent all throughout. It's going to be the same. Iron, copper, sulfur, all of those are pure substances. But do you know what is not? Lemonade. Sorry, Beyonce, it is not a pure substance. What is it then? It's a mixture. Okay, lemonade that you get in one place and a lemonade that you get from someplace else is not the same. Depends on if you're using country time mix. It depends if you are squeezing your own lemons. It depends if Jay-Z does something bad. I don't know, something like that. Okay, so how do we determine whether something is a substance or a mixture? We look at their physical properties. Okay, physical properties are characteristics that we observe without changing what it is. So we're going to use our five senses in order to do that. Okay, like color, look at what color the substance is, solubility, odor, which is the smell, luster, how much shine it has, that's going to tell us if it's a metal or not. Their hardness, how strong it is, what its density is. Oh, we're going to do so much with density this year. Melting point, boiling point, solidification point, vaporization, all those. And if you look into your book, they have all these different common substances like salt and sugar and baking soda and they look at, their colors, their boiling points, melting points. One of my favorite labs that I did in college is they gave us five different vials, and they all had a white solid powder in it, and we had to figure out what they were. So we had to use all the other labs that we did previously in the year in order to figure out what they were. We did our analytical chemistry. We looked and see what temperature they melted at. We saw if they were soluble or not. We looked to see if they interacted with acids or bases, and they looked at all the different kinds of properties. Okay, so one of the things that we look at a lot and that we'll get into with a lot more detail is going to be the state of the substances. So is it going to be a solid, a liquid, a gas? And yeah, there's plasma. It's really rare that we talk about it. That's going to be really high energy particles like the sun and stars. But you know there's a big difference between your solid, your liquid, and your gaseous particles. Okay, we're going to go over this in a ton more detail in chapter 10. We're going to do a VR and AR experiment. That's augmented reality and virtual reality in Google Expeditions. You'll use your phone and the VR goggles. We go to the library in order to figure all that out and have a good place to move around in order to see what the difference is between these things. Okay, but you know this stuff. Okay, this is still pretty elementary. All right, so our solids are going to have this definite shape and volume. They'll slightly expand and contract, but you'll see that they are tightly organized together like so. Okay, you can't really take a rock and make it more of a rock or rocky. You can't take a book and step on it and turn it into a short story. That doesn't work. Your liquids are going to have no definite shape, but they have a definite volume. So you're going to see that things are going to flow and be fluid, but they aren't going to compress. That's why we belly flop, and that's why it hurts. Okay, and then we have our gases, which have no definite shape and volume. And believe it or not, that's considered to be fluid. They're going to flow as well. But they can be expanded and they can be compressed, and that is a really, really big deal. We'll do a whole chapter of gas laws and all their different behaviors and stuff. And we'll talk about what happened to me when I was young and I put balloons in a hot car and I didn't realize that they would expand and pop. Oh, goodness, it made me so sad. And then lastly, plasma is going to just happen at these very high temperatures. Basically, it gets so hot that these substances are going to lose their electrons, and they're not quite the same as your gas particles or as your solids. Okay, these are not plasma TVs. Plasma TVs are something else. Okay, that's going to be your LCD, your liquid crystal display. That is not the same thing as your plasma in this instant. Okay, and when we look at our physical properties, we are looking at the changes those physical properties can do. Okay, you can change the state of matter or change its form, but you're not actually changing what it is. So it's going to be reversible, or it's going to stay and be exactly the same. Okay, it doesn't really change what it is. Like if you melt an ice cube, it can be refrozen into ice. Or if you cut a piece of paper or some bread, yeah, now it's the same, it's just in two different pieces. You can bend something, you can dissolve something, but guess what? You can extract the water and you can dry it out. So if you have your notes along there, okay, dissolving is not a chemical reaction. It is a physical one. And this is possibly the most common thing and that people mess up. And that's one of the things that we go over in lab is we dissolve salt and water and then we take the water out of the salt. And that's really, really important to understand. Okay, so physical changes don't change what we have. They are either reversible or the substance stays the same. Okay, condensation, like we see on a glass in the summertime, breaking, all of those things are physical changes.